What's up, guys? Welcome to Nation Innovation AI tutorials. I'm Sanjeev, and I will be discussing machine learning basics in this session. I've taken the slide from NVIDIA Intel graphics, and I found it quite suitable for this session. So let's start. What is machine learning? Machine learning allows computers to learn and infer from the data. What this term infer means is to refer from the data. Whatever the data points we have collected, it founds a relationship between input and output or among the input, and accordingly it trains our model, and then it behaves in a more human like fashion, in a more human like manner, right? Now we come to the next topic. It is types of machine learning. As I've already discussed in our previous tutorials uploaded on Nation Innovation, you can see from there. But here I will give a brief overview of these three topics, right? Supervised. Data points have known outcome, means we have input, we have output, and we have kind of a relationship. Our model, when it is trained, founds the relationship between input and output, and once we know the relationship, we know the model is being trained, we take that model and apply it to some unknown input and found the results accordingly, right? And accuracy and loss are two aspects of that results, right, which we will see in later sessions. Now we come to unsupervised. The data points do not know the relationship, right? They found because there's no output available, right? We have only inputs, there's no output available. So what they do is they correlate their relationship between their surroundings, right? And accordingly they train themselves, and once they are trained, they are subjected to some unknown input, and accordingly output will be provided, right? In terms of reinforcement learning, what I will say, it is unlabeled feedback for action. Feedback for actions means there is always a reward for whatever actions you are taking, right? There are plus point and negative point. Just like chess, when we see that for every right move from our uh, we cut the points of other opponent, we get the positive points, and similarly if he cuts our pawn or something knight, we get a negative point for that, and accordingly it trains itself, it trains on the basis of feedback, right? So these three are just part of your machine learning, right? Now let's move types of supervised learning. Supervised learning is in this we come to regression and classification. Regression outcome is continuous numerical basis, means when the data points are in values and they want to correlate, they want to find the relationship between itself. So the regression is like just best suitable line, and which fits all the data points, best suitable relationship regression give us to us, right? And in classification, it's kind of a yes or no kind of a situation, true and false kind of a situation, categorical distribution becomes to classification. Okay. Now the third topic is like common application. Common application, we all know: handwriting recognition, language translation. Language translation is like NLP, machine translation, and all the stuff. So much of work is being done in this language translation, right? Speech recognition, image classification, and autonomous driving. All these are like common application of your machine learning, right? Now we come to this machine learning vocabulary. What does that mean? Machine learning vocabulary. These are the terms which we will see more often, right? So it is target, predicted category or values of the data, right? Predicted categories means it's your output kind of thing, right? Target is your output which you want from the model, right? Now, the second is like features. Features is like your like properties of the data used for prediction. Features are your basis on which we will define our relationship, right? Features are just like your it will be useful for training our weights. It tries to define the relationship between input and the output. So feature is very important, right? Example, a single data point within a data one row. It's it's like leave it, right? So label is like the target value of a single data point. Label is means like annotations or whatever you have categorized that thing. What does that particular output mean? So there comes your label, right? Now we move to machine learning vocabulary synonyms, which we will be seeing in our coming videos, right? So target is like response, output dependent variable, and labels, right? It's like all is like output, right? Final value. Now the features is like predictors, input, independent variables, and attributes. Yeah, this is the term which will be using more often. Attributes, right? Features. On the basis, we will define the relationship between input and the output, right? Example is like observation, record, instance, data points, row. Example like observations, what you find, what you infer from whatever you get, right? Record, instance, and data points. Label is like it's again like a your annotations kind of thing. Answer, y value, category, like final in what thing you want to categorize this particular input or inputs output, right? So it's come under the value of label. You label that particular thing. Now what has changed, right? Traditional and machine learning, what have been changed? We have rules, we have data, and we have answers, right? This is our traditional thing, right? So we define the rules, man-made rules. We define as a programmer, we define the rules, and the data we is given. The rules manipulates the data and accordingly gives the answer, right? But here, what we see as the society is becoming so ambiguous, we do not very sure about the rules. The rules are changing at time to time. So for that, what new technology is, we have data and we have answers. We have lot of data and we have lot of answers, and accordingly our model is being trained. And what does training means? Input and output, they are training, they are finding the relationship between x value and y value, and accordingly the rules have been set up, right? And once these rules have been set up, they can be taken to some unknown atmosphere, and they will result in much more good good quality results will be available, right? So what has changed? Just see. So we can see this the body postures are like the sticky diagrams are available, and the body postures are there. So accordingly we will we do not know like what it's kind of an action prediction kind of a thing. We do not know what is him, but on the basis of once we train that, yeah, it is once we train that like this action represents that you are lying down, this action is like you are playing, this actions you are playing, right? So all this stuff will accumulate and results in some kind of a labels. Yeah, to so every picture associated with the labels, with the annotations, that what particular thing is there. And once it has been trained, the model has been trained, then once some unknown input is being provided, and it will find the actions accordingly, right? So here it is also written supervised learning overview. Here we can see data with answers, model, right? Model is not trained, but when it is fit. Fit is the command which we'll be using. So once it is fit, the model is being trained, and data without answers. Data without answers, it's some like ambiguous inputs. Like we do not know what the input is, what the output will be for these inputs, and these inputs are then provided by the models, the trained model, and test or predicted the output, right? So these are like similar things. Similar come with regression, numerical answers, movie data with revenue. It's like similar things, movie data, you have the movie data, and what is the revenue collected by that movie, right? And you have model, you trained it. Now you do not, you have movie data, but you do not know like how much revenue will it generate, or will it generate, right? uh, so we have that model, trained model, and once we give input as a movie data, we can predict the what revenue it will be going to collect, right? So it's going to ease our like the job of financer, like how to finance all that stuff. So machine learning is quite a good stuff, right? Now we can come to classification. It's categorical answers. We have labeled data, right? Labeled data means we have annotations are to associated with the data, with the input, right? What that input actually means. We have that thing, right? And we have model. The model is being trained, and accordingly, when it is trained, training is being done, then unlabeled data, and this model, trained model is being applied, and we're going to get the output accordingly, right? So emails labeled, it's just like an example. Emails labeled as spam and not spam. Model, we fit it, we get the train model, and when unlabeled emails are there, it will predict that it is spam or not spam, right? So I think I need to conclude here only. And from here, I will be from next video, I will make some another video, and because it will take more time, right? So I think you all get a clear outlook of what this thing labeled, unlabeled movie data and regression and classification are all about. We'll be meeting soon in our next video, right? And if you have any queries, the comment section will be down below. So have a nice day. Thank you. Keep subscribing, and if you like my video, you please like it, right? So as it motivates me to make more video. Thank